All right, so a developer produced some code on her laptop, and voila, the application is online and ready to be used by users worldwide. Isn't that amazing? Well, not so fast, cowboys. That's not quite how it works. I know, the perception is that software magically falls from the sky, but things are a bit more complex in the real world. In the real world, you have a lot of different developers, many of them working on the same piece of software. So they have to collaborate, and collaboration is hard. And they just don't write amazing code, they also write bugs. You typically find out about them in the worst possible way. Then you have to fix them. You have to verify that you fix them. And ideally, you want to make sure that you don't write the same bug in the future. Then, before you give your software to real users, maybe you want to try it internally so you don't look too bad if that's possible. And only then, make it available to your users. And what does it actually involve to make your software available to users? Do you need to actually build machines with a screwdriver? Or do you have to install an operating system and put a license key? Oh, and I hope it's secure and that you're not gonna leak all password and credit card information of your users to the first hacker, right? But as a developer, you're probably not the only person worrying that it does not happen. So you have to work with other roles in your organization, many others. And then you probably need to perform upgrades to your software. That's true on your phone and on your laptop. And guess what? It's also true for the software your company develops. And you've probably visited website and suddenly you get this frustrating 404 error or 500. Well, that might happen on your software. So who will detect that for you? Is there a developer that constantly checks that the website is running? And once you've detected something went wrong, what do you do about it? And clearly, that's just the tip of the iceberg. When facing complexity, humans love using tools. So let's go through a few tools human beings have developed to help them with crafting software. First, source code management, or SCM. When you have more than one person doing a task, it gets more complicated. The same is true with code. When you have more than one person working on the same piece of code, you'd better make sure that nobody steps on each other's foot. That's why we have SCMs. They are like file systems where you store your files, except they're focused on collaboration, and they keep track of absolutely every change to any line of any file you store in there. The most well-known implementation these days is Git. Yeah, the same thing as in GitHub or in GitLab. It's actually been invented by this guy who happens to be the same guy who created, guess what? Linux. Yep, he's kind of decent at software things. So you also have a bunch of tools to test things. And there are many things you might want to test for. You might want to test the performance of your application to make sure that over time it does not degrade. You might also want to test the security of your application to make sure that you did not write anything too bogus that would end up leaking all of your data to some hackers. You might also want to test the graphical interface of your application to see if it's working the same way on any browser, on any computer, on any screen size. Oh, and you might want to do exactly the same for mobile applications. So yeah, a lot of testing happens. At the end of this journey, ultimately, you want to bring your application onto a computer where it can run. We call that the deployment. So you need to be able to say what you want to deploy, what version specifically, and on what do you want to deploy it. Is it a machine in your data center or is it in the cloud? How do you even access it? Do you need to deploy other software or configuration along with it? Maybe you need an operating system or routers, or you need pictures, files, databases. I know, lots of questions. It's starting to feel a lot like going to Starbucks. All right, so you get it by now. There are a lot of ducks to put in a row. So how did we do that in the past? And when I mean the past, I actually mean it's still happening like that in a lot of organizations today. So tighten your seatbelt. So since all of this is pretty painful, in the past we had the philosophy that if it is painful, we should do it less often. So we would work on code for a very long time, like a year or two, and then bring it to production. That is, bring it to our users. And then we would collect feedback from our users. We would validate what works, what doesn't work. And based on this, we would start a new iteration and aim at launching our amazing version 2.0 in 18 or 24 months. So yeah, it's pretty freaking long cycles. But at least that way, you would go through those painful steps only once in a while. And the problem with this approach is that you don't know what you don't know. The world around you evolves, and what you thought was a real problem you had to solve might not be the right problem anymore. Or maybe you ask your users the wrong questions, or maybe your beta users thought they needed to solve a problem in a certain way, but they were wrong. Or maybe competitors came up with a better way in the meantime, and what you're trying to build makes no sense anymore. This way of doing might seem to make sense. You just have to apply it to any other field to see that actually it makes kind of very little sense. Let's go through an example. Take IKEA. Let's say that they want to build a new chair and they come up with a fancy design as they always do. Look at this beautiful chair. And so they start refining it, building it, and then they produce 5 million of those chairs, which takes them about 2 years. Then they go to market, put them in their shops, and customers tell them that a chair with 2 legs is not really convenient. So they take that feedback, they burn their chairs and start again. Not to worry, here is the new design. Impressive, huh? So they're going to manufacture 5 million of those again that they will then happily bring to customers in 2 years. It's gonna be such a success. That doesn't quite make sense, right? Well, guess what? Software is exactly like chairs. Sure, you cannot really touch software, it's abstract, but it is still a real cost. If you build software that you don't ship to your customers, from a financial standpoint, it is exactly like if you were manufacturing and building up a stock of chairs in a warehouse. Except with software, you would stock bits in Git, but you would still spend a lot of money paying developers to produce something that would sit on a virtual shelf. Building software for 2 years is the same as stocking chairs in a warehouse. Well, so maybe we could improve that. What if we were to do it faster? That is, with shorter release cycles. What if instead of deploying our application every 2 years, we were to do it, I don't know, every year, or maybe every 6 months, or maybe every 3 months? Why not every week or every day? Well, that's a good idea. Think about it. If your business is able to validate that what you're building makes sense pretty much on a weekly basis, then that would solve a lot of problems, right? Plus, you would only need a tiny virtual warehouse now. That's exciting. But wait, you remember that this process is painful, right? That's why we were trying not to do it too frequently in the first place. Plus, it has a lot of friction. And if you take a process with a lot of friction and just run it faster, well, it mostly gives you heat. So taking a 6-month process and running it on a weekly basis doesn't sound like a good idea. The only option really is to rethink it all. Remove the friction. That's the idea that has been around for a bit more than a decade now. If it is painful, the only way to make it not painful is not to do it less, but to do it more. It's kind of like going to the gym, I've heard. You need to build that muscle and train it. Well, every organization has a ton of tribal knowledge that is distributed across many people's brain in various files, spreadsheets, and so on. Developers have a bit of it, security teams as well, testing people also, and so on and so on. And so it happens to just work almost by luck. People know what they should receive from whom, and they know they'll have to do some work, and then they'll hand over that something to another team. And nobody really gets the full picture, and that's the way it works. What if instead we were to extract that knowledge from all of those people and start writing it down centrally, we could define each step, what comes before and after, what happens when things go wrong, what does it even mean to go wrong, what is okay, what is not okay, and now, what if instead of writing that down on paper, we would actually write it like a formal workflow in a software and let that software orchestrate it for us so we don't have to do it ourselves manually. Oh, and look, this workflow kind of looks like a pipeline. Hey, maybe we should call it a pipeline. And how frequently should we run that pipeline? Maybe every week? Well, that's fine, but if a developer makes a mistake, it will take a week for them to find out about it. Well, maybe we could run it daily then. Or, hey, what if we were to run it every time somebody makes a change to the source code? That would be neat. That way, if something goes wrong, the system could take action. For example, it could either inform specifically a developer that what they did was wrong, but it could really be anything we want, right? It's a pipeline. So it's like we would be integrating all of that code constantly, continuously, to make sure that it's healthy at all time. We could call that continuous integration, for example, or CI for short. And we could go even further. We could actually deliver that software, meaning that it would be ready to be used in the right format at any point in time. And hey, we could call that continuous delivery. And if the software you operate runs in an environment we have full control on, well, it means we could actually automatically and continuously deploy that software anytime a change happens. And we could call that continuous deployment. As you can see, software doesn't fall from the sky. It's a long journey, a complex journey. It involves a lot of different steps and different people, but it's a price to pay to deliver greatness to our customers. Innovative, high quality, secure software. This is essential in a software era. Lastly, zoom back and think about all of the data that sits in those pipelines. What tool you're using, what type of checks you're doing, how much you care about performance versus security or innovation, what you force through those pipelines versus whether you let developers do whatever they want. The CI system orchestrates all of the digital DNA of your organization. It defines who you are, what you value the most, what your priorities are. It's an absolutely strategic asset. And also, it is business critical. If it was to ever be down or broken, you would not be able to deliver any new software at all, even to fix the most urgent security issue you might be facing. Why? Because this is your only path to production. If the journey is down, you can't reach production. So yeah, the software delivery lifecycle is amazingly strategic.